Question number 2 is, if A matrix is given and we are to prove this, and we shall prove this question by the principle of mathematical induction. Let Pn be the statement this. We write this as it is. So we use the principle of mathematical induction and we prove this in steps. Step number 1. For n is equal to 1, P1 is equal to, P1 statement is such that put n is equal to 1 here. So the matrix become, see here, 3 is to power 1 minus 1, 3 is to power 1 minus 1, 3 is to power 1 minus 1, 3 is to 1 minus 1, 3 is to 1 minus 1, 3 is to 1 minus 1. Which is 3 raised to power 0 and 3 raised to power 0 is 1. So the matrix becomes this, which is therefore, which is A is this. Therefore clearly P1 is true. Now in the step number 2, let us assume Pn is true for n is equal to k. K is some n natural number. So replace n by k. Therefore Pk statement becomes A raised to the power k is equal to 3 raised to k minus 1, 3 raised to k minus 1. So Pk is A raised to k is the. Let us assume the statement becomes this. Now in the step number 3, we shall prove Pn for n is equal to k plus 1. The natural number 1 more. Now the statement Pk plus 1 becomes A raised to the power k plus 1, which is equal to, first of all we write down A raised to power k is A raised to k into A. Therefore A raised to power k is by step 2 k minus 1, k minus 1, 3 raised to k minus 1, k minus 1. We write here the matrix value A. Now we multiply the two matrices, first row, first column. First row is 3 raised to k plus 3 raised to k plus 3. So it becomes 3 raised to k minus 1, 3 raised to power k minus 1, 3 raised to 3 raised to k minus 1, and so on. Because first row, first element, first row, first column, first row, second column, and so on. So 3 raised to k minus 1 plus 3 raised to k minus 1 plus, it is 3 into 3 raised to k minus 1, and so on. Now see here, it is 3 raised to 1. So we write this term as 3 raised to k plus 1 minus 1. 3 raised to k plus 1 minus 1, 3 raised to k plus 1 minus 1, and so on. Therefore we see here, so the matrix becomes 3 raised to power k. If we compare this matrix, n is equal to k plus 1, therefore Pk plus 1 is true. Therefore by the 3 steps, all the 3 steps are true. Therefore by the principle of mathematical induction given statement Pn is true for all n belong to the set of natural numbers. Hence the proof of this question.